All right, so the first thing they talk about is something that you are familiar with. It is the y-intercept. The y-intercept of any function has an x-coordinate of 0. So if it crosses the y-axis, automatically you know x is 0. Because anywhere on that y-axis, your x value is 0. So it says it has an x-coordinate of 0, and its coordinate is f of 0. That means when you plug in a 0, you will get what your y-intercept is. Therefore, the y-intercept of the quadratic function, ax squared plus bx plus c, is always 0c. So when it's in standard form, you can go ahead and jump straight to your y-intercept, because if you plug in a 0, this is going to 0 out, this is going to 0 out, and you're going to left with just your constant. So that's why your y-intercept is always 0c. Because the x-intercepts of the graph have a y-coordinate of 0, they are found by letting f of x equal 0. So what does that mean? To find my y-intercept, I plug in a 0. To find my x-intercept, I set it equal to 0. So we're actually going to have to use what we learned in the last chapter as far as solving these. Remember, we solved them by factoring. We solved them with the quadratic formula. And that's how we solved what happens. And so what you're solving for is where that function equals 0. So technically, you're solving for where y equals 0. Well, y equals 0 on the x-axis, which means when you solve for that, you're solving for where those actually cross the x-axis. How does this help us? Well, they give us the example above it, throwing pumpkins, and I think y'all did this in physics, potentially, right? So this is a physics concept, but math is just, the numbers behind the physics. And so if you look at that, the way to calculate what's happening, it actually creates a parabola. Well, it should have if you threw it correctly. All right, and so if you were to throw it with some type of launch or trebuchet or whatever y'all would have built there, then it's going to throw it up in an arc pattern, and then it's going to come back down. You have actually created a parabola. And so the function behind that is going to be a quadratic function. And they can actually predict how high something's going to go. They can predict when it's going to hit the ground based on that parabola. They do it in something as simple as construction, and they do it in something as large as like rockets in space, right? Because they need to know if it goes up, it's going to come back down, and where is that going to happen? And so these are all based on quadratics. And so anytime you create that parabola shape, there's a quadratic function that happens behind it. When you have something like this, there's a couple things that are affecting it. How far off the ground it was when it started, that's important. What is the initial velocity? How quickly was this thing thrown, right? And then the other factor, if you're in physics, obviously gravity is going to cause a little bit of a factor in that as well, right? And so all of those things affect it, how far it goes, how high it goes up, when it comes back down and hits the ground. And so that's kind of behind the science behind some of those things from the physics world. And so when you're finding your x-intercept, think about x-intercept. If you were to draw a line on the ground, the x-intercepts would represent it hitting the ground. So it hits the ground here when it starts, it hits the ground here when it ends. Those you can think of as the x-intercepts, right? When it hits the x-axis here, when it hits the x-axis over here. And so very often you'll have two x-intercepts because that's how it works. Sometimes the point at which it turns is the x-intercept. And so sometimes you'll have one x-intercept. Sometimes you'll have none. Think about a coordinate plane. You could have a parabola that's in the first quadrant and it never goes down far enough. Maybe the vertex is above the x-axis to begin with. And so when you start looking at zeros or your x-intercepts, you're trying to think about where is this going to cross that axis. And so we're going to look at ways to solve for that. First thing is the definition of the word zero. So y-intercept we just call the y-intercept. But zero of a function is actually another way to write the x-intercept. So when you hear the term zero of a function, it is the value where that function equals 0. Well, that function equals 0 at your x-intercept. All right, so your x-intercept is where that equals 0, and it is the x-coordinate of that x-intercept that is called the 0 of the function. So they can ask for the same thing two different ways. They can say find the x-intercept, or they can say find the 0. All right, that's the same method that you're solving. So when you have a graph, it's really easy. If they say state the y-intercept and the zeros, you can look at the graph and figure out where the y-intercept is and where the zeros are. The y-intercept is where it crosses the y-axis. So if you have a graph in front of you and they ask for the y-intercept, look for the point where it crosses the y-axis. And then you can just list it. So y-intercept then is going to always have an x value of 0 and a y value of wherever it crosses. This crosses at 1 to -3. So the y-intercept here is -3. The next thing they ask for is state the zeros. The zeros. Well, we need to find the x-intercepts to find the x value of those. The x-intercepts are always going to have a y value of 0. So that's going to be where this happens, right here and right here. All right, and so I'm going to say, well, this one is at 2, and this one is at 4. So my zeros are the x coordinate of those. So my zeros happen at 2 and at 4. Zeros are the x coordinate of your x-intercepts. So if you have a picture in front of you, a graph in front of you, you're literally just being asked, basically, do you know the term? Do you know the term? Y-intercept is where it crosses. 0 is the x value of your x-intercept, the x coordinate of your x-intercept, or where it crosses that x. So given a graph, it's very simple. If you want to find where it crosses the y-axis and the x-axis, you just look and you name the coordinates, right? But there's not always going to be a time when you have your picture or your graph. And so you need to know how to find it algebraically. Well, we actually did this last quarter. We did it actually in the last chapter. If you want to find them algebraically, there's just two things you have to do. Y-intercept is very simple. You're going to plug in a 0. So y-intercept is the easy one here. For these, if I want to find my y-intercept for A, I'm going to plug in a 0. My y-intercept is going to be what happens when I plug in a 0 here. And just like we did it when we were graphing, everything's going to zero out except that C value if it is in standard form. So in standard form, it's really, really simple. My y-intercept is always going to be 0, and then whatever my C value was, 2. That is my y-intercept. Now to find my x-intercept, I need to set this whole function equal to 0. So to find my x-intercept, I'm going to take this entire function here, 1/2 x squared plus 2x plus 2, and I'm going to set that equal to 0. Now, I will tell you, when I have a quadratic with a fraction, as much as I like fractions, I will get rid of the fraction, all right? And so if it's equal to 0, the easiest thing to do is just multiply by the denominator. Multiply everything by the denominator. Each piece of this gets multiplied by that denominator of 2. And of course, the 0 as well, but it doesn't matter. All right, so on the left-hand side, 2 times 1/2, that actually cancels that fraction out. You just get a 1. 2 times 2x, and 2 times 2. 0 times anything is just 0. This is going to be much easier to solve. Whether I need to solve it with quadratic formula or whether I can factor it, it's going to be easier to solve without a fraction. All right? And so to get rid of your fraction, just multiply everything by your denominator. Now that I have this, remember when you have a quadratic function and you are trying to solve for what your values are, you set it equal to 0 and you either factor it or use the quadratic formula. All right? Now, in this case, this is very easy to factor. I'm looking for factors of 4 that add up to 4. Well, 2 and 2, right? And so for something like this, I'm going to factor it. If it's something really difficult to factor, or if it's something that can't be factored, I'm going to use my quadratic formula, which we will do. So I'm going to factor this, x plus 2, x plus 2. That's how that factors. And remember, my last step is to set that factor equal to 0. They're both x plus 2, so my x is going to equal -2. My x is going to equal -2. So what did I find when I did that? Well, I technically found my x-intercept. My x-intercept is going to be -2, 0. Which means if they want the 0 of this function, then I would just list that -2. -2. The zero of the function is where the function equals 0. Where the function equals 0. All right? And so if it's something easily factorable, you're going to factor it and set it equal to 0. That is standard form. Standard form to find the y-intercept is just 0c. To find the x-intercept or the 0, you're going to set the function equal to 0 and solve. All right? Let's look at vertex form. Vertex form is over here. So vertex form, I can't just automatically pick out my y-intercept. All right? So my y-intercept is not as simple on this one because I don't just have it sitting there like I do over here. For this one, I actually have to plug 0 in, just like I did here, but it's going to not just 0 out. So I'm going to say -2, 0 minus 1 squared plus 8. And then I'm going to do order of operations. 0 minus 1 is -1. -1, when I square it, is +1. And then +1 times -2 is -2. And then I'm going to add 8. Add 8. So you're just going to do order of operations. Just do order of operations here. And you will get your y-intercept. And so my y-intercept when I solve for it is 0, 6. And I have answered that piece of it. For the x-intercept or for the 0, you do exactly the same thing. You set the function equal to 0. So I'm going to take this function and I'm going to set it equal to 0. So I'm going to say -2 x minus 1 squared plus 8 equals 0. For this, it's going to be a little different. I'm not going to do factoring. I'm actually just going to solve for x, just like I would on a basic algebra equation, all right? So to solve for x, think about what you would do. The first thing you want to do is get rid of that 8. All right, so I'm getting rid of the 8. I have -2 x minus 1 squared equals -8. I'm trying to get to that x. So now I'm going to divide out that -2. All right? Divide out the -2. So now I have, on the left-hand side, I have x minus 1 squared equals +4. So how do I get rid of a square? If I'm trying to solve for something, what do I do to both sides if something is squared? Yeah, I'm going to take the square root. So I'm going to take the square root of this side and the square root of that side. To get rid of a square, you take a square root, right? So on the left-hand side, it actually just cancels out that square. I just have x minus 1. On the right-hand side, what is the square root of 4? Yeah, it's 2. But when you have a variable involved, you have to do a +2. And you have to say, well, x minus 1 could also equal -2. Because if I take -2 and square it, I will also get +4, right? And so anytime you have a variable involved and you have taken a square root, you have to say it could be positive or it could be negative. Because 2 squared is 4 and -2 squared is 4. So I have to think about both of those, all right? And now I have two very simple equations to solve. I'm going to add 1 to both sides. So over here, add 1, you get 3. Over here, add 1, -2 plus 1 is -1. I actually have 2 answers here. So my y-intercept will always have at most 1 answer. My x-intercept could be 2. So for zeros, they want the x value of my x-intercept. My zeros are 3 and -1. My x-intercepts, if they wanted that, you would write the 3, 0, the -1, 0. Intercepts are going to be a coordinate. Zeros is just the x value of that. So 2 different types of forms, standard form, vertex form. If you can factor your standard form, factor it and set it equal to 0. For vertex form, just move your k value over, divide by that a, and then square root and solve. So for the first one, they wanted the y-intercept. The y-intercept is just, because this is in standard form, the y-intercept is just going to be 0, c. This being your c. So your y-intercept's really simple on this one, 0, -10. You didn't have to solve anything. For x-intercept, to find those zeros, you have to set this equal to 0, and this is factorable. Factors of -10 that give you a +3. So +5 and -2 multiply to give you -10, and they add up to give you +3. So that's your factoring. And then once you have your x plus 2, x plus 5, x minus 2, set them equal to 0 and solve. Subtract your 5, add your 2. So that's how you got your zeros. You set the function equal to 0. That's where it crosses the x-axis. -5 and +2. Where it crosses the y-axis is 0, -10. All right? For this next one, it is in vertex form. So to get your y-intercept, you actually have to plug a 0 in. So 3, parentheses 0 minus 2 squared minus 4. Do order of operations, 0 minus 2 is -2. -2 squared is 4. 3 times 4 is 12, minus 4 is 8. My y-intercept is 0, 8. For your x-intercept, or your zeros, set this whole thing equal to 0. 3x minus 2 squared minus 4, add your 4 over. Divide by 3, so we have x minus 2 squared equals 4/3. Take the square root of both sides. 4 has a perfect root, that's 2. You did have to say positive or negative for this. 3 does not have a perfect root, so we did square root of 3. Just leave it as a square root if it doesn't have a perfect root there. Then add your 2 over. So we have 2, and plus or minus, because we had that positive or negative root, 2 over the square root of 3. If you'll remember, when we did radicals, you don't want to leave a radical in the denominator. To get rid of it, multiply the top and bottom by that square root to get rid of it on the bottom. And so when you do that, you end up with that 2 plus or minus, and now we have 2 square root of 3. Remember, square root of 3 times square root of 3 is just 3. So zeros, this is where it crosses the x-axis, and then y-intercept, that's where it crosses the y-axis. So anytime it says approximate, it means that it wants it in decimal form, all right? And so if I tell you to do that with something like a, then I'm going to say round to the nearest 10th, 100th, whatever. I'm actually going to tell you how to round it. In this case, they're rounding to the nearest 100th, which is fine. Most of the time for something like a, I'm going to have you leave it in radical form. And so if it is in standard form like a, then we are going to do exactly what we just did for this. Right now, it is just asking for the zeros. So this is not asking for the y-intercept. So when it's asking just for the zeros, you can go ahead and go straight to setting it equal to 0. All right. And then my first step, what's my first step here if I want to solve for this? What do I need to do first? Yeah, I need to subtract that 6. So I have negative x plus 2 quantity squared equals -6. This is a -1 here, so I technically need to divide that -1 out. And I'm going to get the x plus 2 quantity squared equals 6. All right, to get rid of my square, what do I do to both sides? Take the square root. So I'm going to do this. On the left-hand side, that square cancels. On the right-hand side, I have positive and negative square root of 6. Positive and negative square root of 6. Square root of 6 does not have a perfect root. It's just 2 times 3. I can't even simplify that root. All right, so then I'm going to subtract my 2 over. When you do something like this and you have a whole number and a radical, you cannot combine those. Think of it like terms. So I have a -2 plus or minus square root of 6. If I said solve and give me the exact answer, you would leave it just like this. This would be your answer. You can't go any further. If I said round to the nearest 100th, then you would need to put that in your calculator and add and subtract it. I just want to caution you, this is 2 different answers, okay? So if you were to put this in your calculator, you would have to say -2 plus the square root of 6, and you would round that. That would be approximately, I think, 0.45 is what they have there. And then you would also have to say -2 minus the square root of 6. and you would have to round that one. So anytime you do and you have a plus or minus and they want you to actually solve and give the answers, you're going to have two answers. You have to put it in and add, you have to put it in and subtract, okay? If I say I want it exact, then you would actually just leave it like this. That is the exact answer. The rounded answer is what happens when you put it into your calculator, all right? Now, what happens if you have it in standard form and you cannot factor it? So let's look at B. If I set this guy equal to 0, my first thought here is factor, all right? Because that's usually the easiest method when it's something like this. But there are no factors of 3 that give you positive 3 and add to give you negative 2. My factors of positive 3 would be positive 1 and positive 3. If I add those up, what do I get? I get positive 4. Or to get positive 3, I could say negative 1 and negative 3, right? Negative 1 times negative 3 gives me positive 3, but what happens when I add them? Gives me negative 4, all right? Now, if this were a minus 3 at the end, I could factor it, right? Because I would have one positive and one negative, and I could say negative 3 and positive 1, and that would work. But it's a positive 3. This is not a factorable quadratic, okay? You cannot factor it. So then my next thought is I'm going to go to quadratic formula, all right? And so you do have to recall your quadratic formula. That's the only way to be able to use it. Remember, your quadratic formula is negative b plus or minus the square root of b squared minus 4ac. The entire thing is over 2a, all right? My a here is 1, my b is negative 2, my c is positive 3. All right, and so I'm just going to plug it in and solve. Negative b, well, b is already negative, so negative negative 2 is positive 2, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. All right? Then I'm just going to use order of operations. Negative 2 squared is 4. Negative 4 times 1 times 3, negative 12, all over 2. All right, 2 plus or minus 4 minus 12 is negative 8. All right, what happens when I have a negative in the root? What do I need to do to get that negative out of the root? What's my little notation for that? An I, yes. And so I have 2 plus or minus, I'm going to bring out that I, and then I have an 8. So I can actually use a factor tree here. A 2 can come out as well. So I actually have out on the outside, I have a 2i. All right, I took a 2 out here. On the inside, I took out the negative, and I still have a 2 left over. So we're going to put a 2 there. All right. Can I reduce that? Well, yes. If everything on the outside can reduce, I can reduce it. What comes out of everything on the outside? A 2. Divide this by 2, divide this by 2, divide this by 2. So I get 1 plus or minus I square root of 2. All right. And that is your answer. Just like this would be your answer if I wanted it exact. When you have that imaginary number, that is your answer. You're done. So your zeros happen in the imaginary spectrum, imaginary I, and you're done there. In this case, they now want us to graph this particular problem. What do you notice is different about this than the other ones we've been solving? Yeah, we have an inequality here, all right? So we are going to do everything exactly the same, except we are going to now shade, and just like with a line, we have to decide, does it include the parabola or does it not include the parabola? So we may have to dash our parabola or make it solid. So when I do this, I'm going to solve exactly the same. I'm going to say I need my axis, I need my vertex, I need my y-intercept, and then I'm going to graph that parabola. All right, so the first thing I'm going to do is my axis. My axis is negative b, that's negative 4 over 2 times a. So negative 4 over negative 2, that's going to give me an axis of x equals 2. So on this graph, I'm going to draw my axis at positive 2. Just like I would when I was graphing any parabola. My vertex, well, I'm going to take that 2 and I'm going to plug it in. So I'm going to say -2, negative, and then times 2 squared plus 4 times 2 minus 3. So I have -4 plus 8, that is 4, minus 3 is 1. So my y value here is 1. So I'm going to go to the point 2, 1, and I'm going to put my vertex there. My y-intercept is really easy because it's in standard form. It's just 0 and c. So 0, -3 is my y-intercept. I'm going to go down here, and I'm also going to mirror it. That y-intercept is 2 away from my axis. So on the other side, I should have a point that mirrors it. All right, so I have my 3 points to be able to graph this. Now that it's an inequality, I need to decide, is it solid or dashed? So go back to just how you would graph a line. This is less than. Is this going to be solid or dashed? Dashed. If it was or equal to, it would be solid, but it is not. So I am going to dash this parabola. I'm going to graph it with dashed lines here. All right. Now, my y value is above or below that, according to this. Less than. It's going to be below, right? So the parabola is going to be above, the y value is going to be below. Y is less than. So what I'm solving for is going to be less than this. What's a parabola? So what I do is I go to my vertex and I decide what's below and what's above it. Well, below it would be down here. So I'm actually going to shade inside my parabola when it's like this. All right. Had it been pointing up and it said below, I would actually shade on the outside. All right. Had it been pointing like this and said above, I would shave out here. If it was pointing up and I said above, I would actually shade inside of it. All right. And so you have to decide where you are and where you're going to shade. And in this case, I look at my vertex and I say below the vertex. Well, that's going to be inside that parabola that is shaded.